joining this presentation. My name is Dirk Van Rooy. I'm a professor at the Center for Responsible AI at the University of Antwerp in Belgium. And the presentation today will be about human-machine collaboration for enhanced decision-making in governance. So increasingly we're seeing an integration of human-machine collaboration in governance and policy decision-making in all kinds of formats. But what is clear is that there is an increasing reliance on artificial intelligence and automation in these areas. And as AI and automation become more prevalent, it might be interesting to explore how the combination of human intuition and machine precision can actually lead to better outcomes and when it doesn't. So what I'll try to do in this short presentation is just cover the growing reliance on artificial intelligence in a number of sectors and then specifically address the implications for governance. So there's no doubt that human-machine collaboration offers significant benefits, such as enhanced efficiency, improved decision accuracy, and greater innovation. And this is evident across multiple sectors, including healthcare, finance, transportation, and indeed the public sector in general. For instance, in healthcare, AI systems like IBM's Watson already assist in disease diagnosis, showcasing how machine intelligence can augment human expertise. Now, to better understand how HMC can be implemented, we need to delve into the various levels of automation involved in such collaborations. So let's perhaps start with exploring a framework that was developed by Simler and Frischknecht, which categorizes these levels and helps us identify the right balance between human oversight and machine autonomy. So what I'll try to do on this slide is just go into a bit more detail in terms of this framework developed by Simler and Frischknecht. My argument is essentially that understanding these levels could prove quite useful for determining the appropriate balance between human oversight and machine autonomy in various decision-making scenarios. So let's perhaps have a closer look at these different levels. So level 1, decision support. At this level, the machine acts as a decision support system, providing options for the human operator to choose from. Classic example is a GPS navigation system, for instance, that proposes multiple routes, but the driver ultimately decides which route or route to take. So this level emphasizes human control with machine assistance, ensuring that final decisions still remain in human hands. Level 2 then, here the machine selects an action but requires human approval before executing it. So a common example here is a thermostat system that suggests temperature adjustments based on weather forecast, for instance, but waits for homeowner confirmation before making any changes. So this level ensures that humans remain actively involved in the decision-making process. Then the third level, execute if no human vetoes. So at this level, the machine can execute actions autonomously unless explicitly vetoed by a human. So automated spam filters, for instance, in email services, which automatically sort messages unless manually overridden, exemplify this level. So this setup reduces the human workload while still allowing intervention when necessary. The fourth level then executes and then informs. Here the machine acts independently, but it informs the human afterward. So an example is a security system that locks doors at a predetermined time and then notifies the human operator or security personnel. So this level allows machines to handle usually routine tasks while keeping humans informed, ensuring transparency and accountability. Then the fifth level is full automation, so executes fully automated. So at this highest level, the machine operates entirely independently without human intervention or notification. Although this is still pretty rare, there are examples of this. For instance, autonomous drones are used for geographical surveys in remote areas in this way. So while this level maximizes efficiency and operational speed, it also requires robust systems to ensure reliability and also address any potential issues that may arise without human oversight. It is obvious, for instance, that in critical defense operations, this level could be quite problematic. Now, the wider argument I'm making here is that understanding these levels of automation could prove to be crucial. But equally important is recognizing the cognitive biases on the human decision side that could impact decision making at each of these levels. So let's perhaps move on to examine these biases and their implications. Quite unsurprisingly, it turns out that human decision making is often influenced by cognitive biases, leading to inaccurate or suboptimal outcomes. And there's many examples of these biases, anything from anchoring, confirmation bias to automation biases. And some of these names will undoubtedly sound quite familiar. I guess the key argument I'm trying to make here is that recognizing some of these biases could prove quite useful for improving decision quality, especially when integrating with AI systems. Not going in too much detail, let's just perhaps look at some of these biases and how they might actually play out in governance. So for instance, a confirmation bias typically involves favoring information that confirms pre-existing beliefs and undervaluing information that contradicts them. So for instance, during an environmental assessment, an analyst might focus on data that supports their belief that a particular project is actually beneficial, while ignoring evidence of, for instance, potential environmental harm. Another good example is the anchoring effect. So this is the tendency to rely too heavily on the first piece of information encountered when making a decision. So for instance, a policymaker might base their budget decisions on initial cost estimates without adequately considering subsequent data, leading to a suboptimal allocation of resources. Another classic example is the loss aversion bias, which makes individuals more sensitive to potential losses than equivalent gains, which can influence policy decisions to favor options that minimize risk or loss, which is not always a bad case, obviously. But this tendency can result in overly cautious or conservative policies, potentially hindering progressive or necessary reforms in favor of maintaining a status quo. So, as I mentioned, I'm not going to go through all of these biases, but having identified some of them, it might be good to develop an understanding of what some of the underlying cognitive processes could be that drive them. And although not perfect, and certainly somewhat of an oversimplification, a good framework here is the dual process theory. So the dual process theory basically distinguishes between fast, or type 1, and slow, or type 2 thinking. So the framework was popularized by Daniel Kahneman, and it is argued that the government and industry was quite fast to pick it up, but fairly slow to learn its limitations. So the truth is probably a bit more subtle than this framework suggests, but in itself the framework can be quite useful. So what is type 1 thinking? Well, type 1 thinking is automatic, instinctive, and rapid. So it operates subconsciously and does not require working memory. So it relies quite heavily on heuristics or mental shortcuts, which can then lead to the type of cognitive biases that we've just seen. So type 1 thinking would be the type of thinking that you would most rely on in your day-to-day business. It is argued that about 80% of our behavior relies on type 1 thinking. Type 2 thinking, on the other hand, is controlled, slow, and conscious. So it involves careful processing of information, evaluating options, and considering consequences. This type of thinking has a limited capacity, but it is essential for complex decision making. So, for instance, when you're deliberating over financial investment options by analyzing market trends or forecasts or looking at your pension options, you are likely to rely on this type of thinking. Now, both types of thinking have some consequences or implications for the way that you design human-machine collaboration or your AI system. So when dealing with type 1 thinking, what you try to do is develop a system that aligns with the mental models and cognitive maps of your users. So you want to make sure that your users can make quick, intuitive decisions based on current conditions. A classic example of this would be a navigation system like Google Maps, which really aligns very strongly with our mental models and our cognitive maps, and which makes it easy for us to use Google Maps in a very intuitive way. In terms of type 2 thinking, our AI systems should facilitate at the right time an analytical mindset by providing ample information and tools for data analysis and decision making. So they should motivate users to engage in thorough evaluation and critical thinking. So an example of this, as I've already mentioned, would be, for instance, an AI-driven financial analysis tool that offers detailed reports and scenarios, sometimes conflicting scenarios, and that could then support informed investment decisions. So with a little bit of an understanding of some of the cognitive processes that potentially underlie human decision making, we can now examine how automation would interact with these processes. Now, research suggests that there might not be a direct linear relationship between specific levels of automation and specific cognitive biases, but it is certainly the case that certain biases are slightly more likely to occur at different levels of automation. So for instance, if you look at level 1, decision support, so at this level, biases such as anchoring and confirmation are likely to be more prevalent because humans are still pretty much heavily involved in the decision-making process. So how would this manifest itself? Well, a policymaker might focus too much on the first option suggested by the system, or seek information that supports their pre-existing beliefs. How can we mitigate this? Well, the AI system could mitigate the impact of these biases by offering a broad spectrum of choices and making the decision process transparent, thus ensuring that biases like anchoring and confirmation are less likely to occur. At the second level then, human approval, you're likely to see biases such as overconfidence or automation bias. Humans might overestimate their understanding of the system's suggestions and blindly trust the automated recommendations. So for instance, an operator might approve a system's recommendation without critically evaluating it, believing in the system's infallibility. How can we avoid some of this? Well, by educating users about the risks and also providing regular training to help maintain a sort of critical engagement with the system's recommendations, and in general just make people aware of such a thing as automation bias. And the third level, the veto power level, at this level status quo and omission biases are more likely. So humans might prefer not to intervene, which is a status quo bias, or just avoid making active decisions due to fear of negative outcomes, which is the omission bias. So for instance, a manager might let an automated system's default action proceed to avoid responsibility for potential errors. So how can we avoid some of this? Well, by implementing active confirmation requirements and feedback mechanisms to ensure that users remain engaged and responsible for the critical decisions. Level 4 then is all about informed action. At this level, hindsight bias and automation bias are probably more prevalent. So humans might believe they could have predicted the outcomes after the fact, which is a hindsight bias, or not question automated actions due to over-reliance. You can probably already intuitively understand here that the difference between this level and the previous level, level 3, is not always clear, and it's very likely that some of the same biases will occur on the different levels. But certainly at this level, the level of informed action, you would expect that allowing a human operator to conduct some post-decision analysis and also providing regular updates could potentially reduce some of the bias that we're seeing here by fostering critical assessment and continuous learning, thus reducing the impact of biases such as the hindsight bias and also automation biases. Then at the final level, the full automation level, the greatest risk here is what we call out of the loop unfamiliarity, where human operators are simply so unfamiliar with what is actually happening that they restrain from making any type of decision. So humans can become detached from the decision-making process and thus lose the availability to intervene effectively when needed. So for instance, a policymaker might not understand a system's operation well enough to step in, for instance, during emergencies. How can we mitigate some of that? Well, ensuring periodic engagement and also training, simulation training, could help maintain human familiarity with automated processes, thus allowing for a more effective intervention when necessary. Now, although this system is certainly not perfect, and as I mentioned, the relationship between levels of automation and particular cognitive processes is certainly not perfectly linear. I do believe this kind of system can help us look at some of the human-machine collaborations that are taking place in governments today. So what are some of the challenges and opportunities here? Well, the challenges are likely to be situated on three different levels here. First of all, there are clear managerial complexities. So integrating AI and human decision-making processes involves significant managerial complexities. This includes aligning goals, ensuring effective communication, and managing the different expectations and understandings of AI capabilities among stakeholders. For example, coordinating between different government departments and AI developers, for instance, to ensure that the implemented systems meet the specific needs of each department can be a bit of a challenge. In fact, we know this from existing literature that this is one of the things that can often go wrong. A second a key challenge here is a discrepancy in AI understanding. There's often a gap between the technical understanding of AI among researchers and the practical understanding among policy makers. And this discrepancy can lead to unrealistic expectations or misuse of AI systems. So policy makers, for instance, may expect AI systems to perform flawlessly without understanding their limitations and the need for human oversight. And then, as I've already discussed in some detail during this presentation, there's the risk that human cognitive biases can significantly impact the effectiveness of human-machine collaboration within governments. So biases like overconfidence, automation bias, and status quo bias, etc., can definitely lead to poor decision-making if not properly mitigated. The example I gave of that was an over-reliance on AI recommendations without really critically evaluating the system's recommendations. And then in terms of opportunities, there's obviously quite a lot of opportunities here as well. There's no doubt that AI and human-machine collaboration can significantly improve the efficiency of decision-making processes by leveraging the strengths of both humans and machines. AI can quickly analyze vast amounts of data and provide insights that help policymakers make faster and more informed decisions. It can also lead to enhanced public service delivery. So AI systems can streamline processes and provide personalized services, leading to better public service delivery. Classic examples of this are already around us, with AI-driven chatbots handling routine inquiries and freeing up human staff to focus potentially on more complex tasks. And if we use AI in a responsible way, it can lead to more informed and responsible decision making. So by combining human intuition and expertise with AI's analytical capabilities, human-machine collaboration can in fact lead to more informed and responsible decision making. We're already seeing some of that in, for instance, urban planning, where AI can provide data-driven insights, while human planners can consider ethical and social implications. So to conclude, what I'm basically arguing for here is, I suppose, the balanced approach. So a balanced approach to human-machine collaboration, leveraging both human cognitive strengths and machine computational capabilities while also taking into account limitations on both sides of that equation. It's only this type of approach that will ensure that decisions are both data-driven and contextually informed. Um, One part of that involves, as we discussed in this presentation, mitigating some of the known cognitive biases that plague human decision making. And addressing some of these cognitive biases could prove crucial for effective HMC. So by implementing strategies such as diverse option generation and transparent algorithms, it is likely we can mitigate some of these biases and overall improve decision-making quality. But certainly future research would have to take a closer look at scenarios that require both type 1 and type 2 thinking. As I've already pointed out, the dual process theory, although quite useful and practical in terms of analyzing some of the existing collaborations, is likely to be oversimplifying what actually takes place in terms of human decision making in governments. It is likely that most decisions and most policy processes, are a mix of type 1 and type 2 thinking. So certainly that more subtle aspect, those more subtle interactions need to be explored in a bit more detail. But in the end, the goal is to develop a sort of technologically advanced, while also cognitively attuned AI system. So develop governance systems that are both technologically advanced, while also supporting their human decision makers, taking into account their strengths and their weaknesses. So in conclusion, human-machine collaboration and AI systems in general certainly hold great promise for transforming governance and policy making, and by addressing the challenges and leveraging some of the opportunities, I'm quite confident we can create more efficient, informed and responsible governance systems. Thank you for your attention.